All right, here we go. Welcome to class. Jaden, turn around. Donovan, put down your phone, look at the board. I mean your computer screen. All right. Hey, we just finished chapter 9. We're ready to go for chapter 10. So there was no homework to correct. Normally, like starting tomorrow, this slide would be as normal. I'll call out the answers. You're going to grade your homework, and then I'll ask you to, in the Google Forms, write down how many you missed. But today, no homework to grade. Here we go. This is the calendar. We're going to get through all the way through 10.3b, and then we're all going to go on spring break. We come back right now. We're scheduled to do CMAS prep for a week, and then we take the CMAS test. That's what your future looks like. All right, copy down your homework. I'll show you this again at the end of the slideshow. And just remember, since this is literally a video, you can pause, rewind for anything you need to hear a second time. All right. Today's lesson is areas of rectangles and parallelograms. This entire chapter is on area and volume. So this is a calculator section, so you may use your calculator on all the problems and the test when we eventually take your test. All right, two objectives: calculate the area of a rectangle and parallelogram, and calculate the perimeter of a rectangle and that says perimeter, it should say rectangle and parallelogram. Okay. All right, new idea. You may not know it right now, but that is a rectangle. So a rectangle, if we were to measure the sides of this rectangle, for instance, we might find that this particular one, the length is 10 inches and the width is 3 inches. Okay? So the question to you is, well, how much space is on the inside of this rectangle? Think about that for a second. How much space is on the inside of this rectangle? Now, some of you probably already know the answer, but what we're talking about for everyone else, write this down, please, is area. That is what answers that question of how much space is inside the object or enclosed by the particular shape. We're going to do lots of shapes this section or this chapter, and each one will have an individual formula for calculating area. But the definition of area is the space enclosed by a shape. It doesn't have to be a rectangle, it could be a circle. All right, we're going to come back to this and write some more definitions next to the word area in a second. But for right now, let's pause and let's do some more thinking. So let's go back to our rectangle. Imagine this. If I made another smaller rectangle, in fact, I'm going to make a square. And I'm going to measure the square on all its sides. And for instance, let's say the square is 1 inch on one side, 1 inch on the other side. In other words, all four sides are an inch. And I were to take that, if I were to take that square and draw the same square up here, and how many times could I draw the square? Well, we would fill it with a whole lot of squares, right? This particular square here, here, so forth and so on. In fact, it would evenly fill up with squares. If I were to count the number of squares, 1, 2, 3, blah, 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 eventually I would get to the final number. And that final number is, well, for those of you that already knew the answer to this and probably can see where I'm going with this, there's 30 squares. So in other words, there are 30 squares in this shape. And each one of those squares is an inch by an inch. This, ladies and gentlemen, is the concept of area and how area is measured. Area is literally, I mean literally measured in how many squares can fit inside a shape. So when we say the answer to how much space is enclosed by the shape, we fill it full of squares and count the squares. This particular one had 30, so we say for units, we say 30 square inches. We can also use an abbreviation, IN for inches, and to the second power, this is why I told you way back when we did exponents, anything to the second power is called square. Inch times an inch gives you inches squared. Either one of these is acceptable, 30 square inches or 30 inches squared. Typically, we say the answer with this form right here. However, I don't want to say we're lazy, we're efficient. We write the answer like this. So get used to this. All right, so back to our definition, area, space enclosed by a shape. Put this comment as well too. Area is measured in square units. If there's any problem tonight for homework and they don't give you the inches, centimeters, miles, kilometers, you're going to put square units. Here's an example. 30 square inches However, most of you will probably write it like this, 30 inches squared. And it can be said either way. Okay, so what? So what is this good for? Well, rectangles are the easiest one to calculate, and that's why most math books start off with rectangles to measure. Okay, well, once again, they're easy because all I have to do is fill it full of squares and count how many squares, right? Or is there an easier way? Well, there is, and if you can remember from the original dimensions, the length was 30. I'm sorry, the length was 10, and the width of it was 3, and 3 times 10 is 30. This is where we get our formula for area of a rectangle. So first of many formulas, if you want to start a resource card right now before the test, it would be a pretty good idea. This is your first formula. Now notice its form. It says area, and then underneath of it, it says the shape that we're calculating the area of. So the area of our rectangle is equal to length times width. So write that down as our first formula. Now we're also going to be doing a second calculation today, and that's called perimeter. And perimeter is defined as simply the distance around an object. So if we were to write a formula for perimeter, second formula, well, let's see, going around a rectangle would be 2 lengths and 2 widths, right? Because remember, the opposite sides of a rectangle are equal. We got that from our previous chapter's study on rectangles. So 2 lengths and 2 widths, or simply just calculating or adding up all the distances around the shape itself will get us the formula. Some people never write this formula down because they always know that perimeter is simply add up all the sides. However, I do want you to make sure you definitely write down the area formula, length times width. All right, if you ever have to rewind the video and go back to this particular part to write down the formulas, please feel free to do so. All right, so let's do some examples. All right, so you're given that it's a rectangle. It literally says calculate the area and perimeter of a rectangle. And it doesn't matter the order. We're going to be doing area first and then perimeter. All right, so here's our rectangle. We know the formula is length times width. There's a big argument of which one's the length and which one's the width. If you want to call this, this your L and this your width, that's fine. That's what most people would do. Just remember that the opposite sides of a rectangle, are equal. So if this is the W, then 9 is the W. If this is 4, then the length is 4. So to do our calculations, we simply plug in the numbers, 4 times 9. 4 times 9 is 36, but remember our units are going to be in square units, and they're centimeters, so 36 centimeters square. I hope this isn't brand new idea to most of you. You should have learned area of a rectangle and perimeter of a rectangle in previous grades. Okay, so this is a two-part question. The second one is calculate the perimeter. Well, the formula for a perimeter is 2 lengths and 2 widths. So 2 lengths would be 4 and 4, this side and this side. Or in other words, I'm simply going to add up all of the lengths of the sides of this 4-sided quadrilateral. So this side, since this side is 4, this side is 4. Since this side is 9, this side is 9. So 4 plus 9 plus 4 plus 9 would be one way to do it. However, you can use this formula. 2 lengths would be 2 times 4, right, because there's 2 4s. And 2 times 9 since there's 2 9s. Follow PEMDAS, 2 times 4 is 8, 2 times 9 is 18, and 8 plus 18 is 26. I almost said 36. Notice there is not a relationship between area and perimeter necessarily, like one is not always bigger than the other. They're each separate calculations, so do each one separately. Notice I didn't put a square on perimeter because perimeter is simply the distance, not the area. Area is always squared. Distance is always just plain old units. Make sense? Okay, let's do one together. On your paper, draw this rectangle for me. Okay, let's calculate the area and the perimeter. If we talk too fast, feel free to pause, rewind, catch back up, and then continue. So the formula for area of a rectangle is length times width. The length is 11. The width is 3. 11 times 3 is 33. We attach our units, centimeters, and remember, since we're calculating area, centimeters squared. Cool? Got it? Okay, let's do perimeter. Perimeter is 2 lengths and 2 widths. Well, the length right here is 11. The width is 3, so I need 2 11s and 2 3s. 2 11s and 2 3s. 2 11s would be 22. 2 3s would be 6. 6 plus 22 is 28. And remember, once again, units are not squared for perimeter, but they are for area. All right, if you need to look at this again, rewind it, play it again. But for the rest of us, let's see if you got this. All right, there's our rectangle. I turned it sideways. I want you to, on your own, calculate the area in the perimeter. And then what I want you to do for questions 2 and 3 on the Google form, I'm sorry, questions 1 and 2 on the Google Forms, I want you to write your answer. The Google form will tell you, what's the perimeter, I'm sorry, it does area first. What's the area of the rectangle in box 4? And then ask you the next question, what's the perimeter of the rectangle in box 4? So do both of those. Go ahead and pause the video, get to both calculations, and then type your answers into the Google Forms, and then press play, and we'll check our answers. Okay, how'd you do? Let's check. Well, the first thing we wanted to calculate area. It looks like the length is 14, the width is 5, so it'd be 14 times 5. 5 times 4 is 20, carry your 2. 5 times 1 is 5, plus 2 is 70. So we get 70 centimeters squared. I hope you got that one right. If not, check what you made your mistake on. Let's see if we can do it right the next time. All right, the second calculation was the perimeter. We need 2 lengths and 2 widths. 2 lengths would be 2 14s. 2 widths would be 5, or 2 times 5. 2 times 14 is 28. 2 times 5 is 10. 28 and 10 is 38. And remember, the units are not squared. Makes sense? I hope you got both of them right. All right, moving on. New shape. All right, the next shape is something called I know this is a rectangle right here, but we're going to draw a shape right here. So I want you to draw a parallelogram. You've drawn that before. That's your basic shape of a parallelogram. So take a moment, pause the video, draw a parallelogram. Okay, we're going to label the parts of the parallelogram, and down here we're going to write what those definitions are of those parts. So any one of the 4 sides can be called the base. Now, yes, we usually put the bottom as the base, but remember, any one of these 4 sides could be called the base. That's our first definition. The base of a parallelogram is any one of the 4 sides. The second definition, right? And just the key point there is any. Notice the parallelogram could be standing up right here, and now the base, if I leave it on the same side, is over there on the left. So if I didn't change the base, it would be over here. I also could have chose this side to be the base, and if I chose that side, then the base on this picture would be right here. So any one of the sides can be the base. All right, if we measure the distance between the base and the opposite side, all distances are measured perpendicularly. If we measured the distance perpendicularly from the base to the opposite side, I'll draw a little line there. Typically, we put dotted lines when we're measuring this. Notice there's a little square right here indicating that it's 90-degree angle, right angle, or perpendicular. That distance we're going to call the height. So label and write the definition. The definition is the perpendicular distance between the base and the opposite side. The perpendicular distance between the base and the opposite side. When you're trying to find the height of a parallelogram, always look for the little tiny square. The little tiny square touches the base, and it is part of the height. In other words, it's attached to the indicator of how long the height is. Now, there will be numbers here. There won't be the words base and height. Now, take a look at this one. If this is the base, well, the height isn't now going to go from top to bottom, because remember, the definition of height is the distance between the base and its opposite side. So on this one, the height would look like this. And you will see this many times, especially tonight for homework. Okay, so your definition should be there, your labeling should be there. So if I were to give you a shape and ask you to name the parts, right? We're not typically I would have handed this as a worksheet, but you don't have that right now. You simply pick one side to be the base, you draw one line that goes from the base to the opposite side. That's your height. And I will say this is generally how you will see parallelograms drawn. There is one thing I need to show you though, okay? And that is sometimes when this parallelogram is really slanted, like that one right there, and we try to measure, if we say the bottom is the base, and we try to measure the distance between the base to the opposite side, we would have to draw a curved or a slanted line because it wouldn't be perpendicular if we drew it straight. If we draw it straight up, I never reach the opposite side. So you will see this occasionally. And what they do to get around this problem, notice I'm not touching the top right there, what they do is they simply extend or they label the height as literally from top to bottom. So be ready for this particular one. It shouldn't confuse you too much. Okay? So it's saying the distance between the top and the bottom would be whatever number is written right there. Notice the dotted line is not inside the parallelogram 9. 9 times out of 10 it will look like this, but occasionally for these really slanted ones it'll look like this. Make sense? Okay. All right, so we got to measure the area. Well, the perimeter would be the easy part, right? It's still going to be all the four sides added up. But measuring the area, well, we've got a problem. If you try to put little tiny squares in there, well, that one fits, that one fits, that one fits, that one fits, and then you're left with this big empty space right here that one of these squares doesn't fit. So that's an issue, right? What is the area of a parallelogram? So the way we get around that is this. I'll show you where the formula comes from. Okay, we take a parallelogram, we assign the bottom as the base, and we measure the distance between the base and the opposite side. And notice I didn't measure it from here to here. Suspiciously, I measured it from here to right there at the vertex right there, right at the corner or the upper left corner of the parallelogram. Now imagine this. If instead of this being a dotted line, I were to say that's where I want you to take a pair of scissors and cut this shape, right? That would be the height necessarily. And we were to cut it right there, you'd make this nice little triangle. And if I took that triangle and instead I moved that triangle to the other side, it would match up perfectly because it's a parallelogram. Well, if I moved it to that side, it's no longer here on the left side, so let me erase that, okay? And since the distance never changed, therefore the bottom is now the base, and the height is right here. In fact, what did I just make? Yeah, I made a rectangle. We know the formula for rectangle, area of a rectangle. It's length times width. Except the difference is in a parallelogram, the length is called the base, and the width is called the height. So it's base times height. That's the formula. So the area of a rectangle is length times width. The area of a parallelogram is base times height. But notice it's just, it's the same basic concept. Let's write that down. Okay, the formula for area of a parallelogram. Area, parallelogram. This is called sub-notation, like a submarine underneath. This doesn't mean anything other than the name of it. So the area of a parallelogram is base times height. Remember, base can be any one of the sides, and the height is the perpendicular distance between the base and the opposite side. You want to find where the base and the height are? Look for the tiny little square right here. It touches the base, and it is the height. The parallelogram is the first shape where we can have extra information. For instance, the distance between here and here could be listed. That's not the width, that's not the height, and that's over here as well too. This isn't the width, this isn't the height, okay? The base is any one of the four sides, and the height is this dotted line right here. The cool thing is it's a pretty easy calculation. You just multiply the base times the height. All right, let's see an example. So this one's pretty easy. There's only two numbers there. Clearly, this is the base and this is the height. How do I know that? See the little square right here? The square touches the base, and it also is the height, if that makes sense to you. So all we do is multiply 20 times 5, which is 100. The units are in inches, so 100 square inches. Cool? All right, let's see one where we have extra information. Check it out. This side right here, from here to here, is 3 centimeters. This is not the height. Notice the height is over here where the square is, the little dotted line. This isn't wrong information. In fact, we'll use it when we calculate perimeter, but we don't use it when we calculate area. The area is the base times the height. Now, in all these ones, I've been making the bottom the base. Just be careful. The bottom doesn't always have to be the base. It could have been this side that is the base. Then the dotted line would go in this direction. Okay, but on this particular one, base times height, 8 times 2 is 16. The units are centimeters, so 16 square centimeters. Cool? All right, let's do one of those really slanted ones. Notice the base is here. Well, there's no dotted line, but this is saying from the bottom to the top, from this base to that base, is 12 miles. Therefore, the base times the height would be 3 times 12, which is 36, so 36 square miles. Now, if you need to, review these 3 examples that I just did, because the next slide is going to be you doing it all by yourself. So there's going to be 4 questions. The next 4 questions on the Google form, it'll say find the area of the parallelogram in the upper left, the red one here, then the blue one. Then if you can't see right here, this is kind of small. This is 4 inches right here, and this is 3.6 inches right here. I think the rest of the numbers are pretty clear. Okay? All right, go ahead and pause the video, find the area of all 4, and put those answers into Google Forms, and then play the video and come back and check your answers. Okay. First one, upper left, the answer is 48 square inches. 12 times 4, 48. Second one, bottom left, the base is 5, the height is 11. 5 times 11 is 55, so 55 square centimeters. This one, it's got this little extra information, 5. That's not part of the height. The height is the dotted line. It's the 2 numbers that touch the square, 21 and 4. 21 times 4 is 84. It's measured in inches, so 84 square inches. The last one, the base is 6.5. The height is 3.6. So the answer is 23.4 square inches. Did you get them all right? All right, good job. Okay, there's a big but right here. And the big but is perimeter, right, is going to use that extra information. The perimeter will not use the height. So even though your parallelogram may have that dotted line, and when you're calculating perimeter, you don't use that. Do we need to write a formula for perimeter of parallelogram? Well, if there was a formula, it would be the top plus the bottom plus the left plus the right. Or two tops plus 2 lefts or 2 rights. Because remember, opposite sides are congruent. In other words, their values are the same side. Typically, at this point, we kind of forego the formulas for perimeter because they're just simply the 4 sides added together. Okay? But for those of you who need to write it down, write it down. This is what I would probably do. 2 tops plus 2 lefts. Or 2 bottoms plus 2 rights. Or any combination of that. Okay, let's do one. So check it out. Okay, we got a parallelogram because it says that. It says calculate the area and perimeter of the parallelogram. So let's see. Let's do area first. So if we do area first, we need the base and the height. The base is 4. The base is 4. The height is 9. 4 times 9. I said 12. I'm sorry, base and height. I just messed that up. I apologize. The base is 4. The height is 12. Base is 4. The height is 12. 4 times 12 is 48. For the perimeter, add up all the sides. Add up all the sides. Well, if this side is 9, then this side is 9. If this side is 4, then this side is 4. So if we add up all the sides, 9 plus 9 is 18. 4 plus 4 is 8. 18 and 4 is, 18 and 8 is 26. All right, so 26 miles. Notice once again, the units are not squared. The units are not squared. For perimeter, they are for area. Got it? Okay. All right, last 2 that we'll do right here. Once again, go on Google Forms. It's asking for both the area and perimeter of both shapes. There's 4 questions right here. Area of this one, perimeter of this one. Area of this one, perimeter of this one. So do the area first of this one, then the perimeter. Type those answers into Google Forms. You'll see the questions. And then the same thing for this green one right here. Pause the video and then come back and check your answers. Okay, how do you think you did? Let's check. So this first one right here, let's see. To calculate the area, we need the base. The base is 10.2. The height is 8.1. Multiply those together, and we get 82.62 square inches. To calculate the perimeter, that would be this side plus this side plus this side plus this side. Remember, if this is 10.2, this is 10.2. If this is 9, this is 9. So we're going to exclude this measurement right here, 8.1, the height, in the perimeter formula. So when we add up all of those numbers together, that would be 18, that would be 20.4, and 18 plus 20.4 is 38.4 inches. Notice not square inches because we're doing perimeter. Hopefully you got that one right. For the last one, the green one, let's see, the base is 2, the height is 8. 2 times 8 is 16, so 16 square centimeters. If this side is 2, that side is 2. If this side is 10, that side is 10. So when we do the perimeter, 10 plus 10 plus 2 plus 2. 10 plus 10 is 20. 2 plus 2 is 4. 20 and 4 is 24 centimeters. Cool? How many of you got all those right? Excellent. Okay, so today we calculated the area of the rectangle, and we did the perimeter of, not the perimeter, we did the perimeter of the rectangle in parallelogram. All right, that's it for today. So here's your homework. Make sure you do your homework. Tomorrow we'll go over the answers to the homework. I'll call off the answers. You'll check, and you'll write that answer into Google Forms. If you run into any problems today, don't hesitate to send me an email, and I'll help you out with your homework if you need to. All right, have a great day, and I will see you guys tomorrow morning.